All right, ladies and gentlemen, we are done with adding and subtracting fractions. Now we're going to focus on multiplying and dividing, starting with multiplying. So here we are at 11:1, multiplying whole numbers by fractions. This should be quick and easy, painless. You just got to learn what to do with it and do it when you see it. All right, so what are some ways to think about multiplying fractions and whole numbers? Here's a problem. How many cups of orange juice are needed to make 8 batches of a fruit drink? 6 cups of orange juice are needed to make 8 batches of punch. And there's 3 cups of orange juice per batch. And it says that right here. 3/4 cup of orange juice for each batch. Well, I know the numbers that I need to work with are 8 batches and 3/4 in each batch. So one way I can work with this is by just using repetitive addition. I can take my 8 times 3/4, which would be my problem, 8 times 3/4, and I can just say 3/4 plus 3/4, 2 plus 3/4, 3 plus 3/4, 4 plus 3/4, 5 plus 3/4, 6 plus 3/4, 7 plus 3/4, 8. That's 3/4 added 8 times. And when I would add all those 3's up, I would know that it's just 8 times 3, which equals 24. And I keep my denominator the same since they're all the same. So 24 over 4 means 24 divided by 4. And that is simple. It's 6. So when you write an improper fraction as a whole number, you just divide. 24 divided by 4 equals 6. And that's how they got the answer of 6 cups of orange juice are needed. Another way of thinking about it is just to simply multiply. So instead of writing 3/4 out 8 times, you can just simply multiply. So you would take that 8 and you'd multiply it by 3/4. So 8 times 3 is 24. Your 4 stays the same. 24 over 4. Then you divide it out. 24 divided by 4 equals 6. So 6 cups of orange juice are needed to make 8 batches of punch. I'm going to give you a little preview into some of the future lessons. When you see a whole 8 like this and 3/4 next to it, it's kind of confusing a little bit because I see a whole number and a fraction. So I always imagine that 8 would be over a 1 and that 3 would be over a 4. And that makes me multiplying a lot easier because I would just multiply across. So 8 times 3 is 24 and 1 times 4 is 4. That makes a lot more sense to me than pretending I'm just multiplying the whole number by the numerator. So whatever works for you, works for you. Let's go ahead and try some of these together really quick. So if I have 1/7 of 14, I would pretend that 14 was over a 1. And then I would multiply across, so my numerators, 1 times 14 is 14. 7 times 1 is 7. And I know that if I really needed to, I could take this and go like this and think how many 7s can go into 14. But I know that already because 7 goes into 14 twice. Okay, let's try the next one. I'm going to pretend that 25 is over a 1. 25 times 1 is 25. My fraction, my division sign. And then I'm going to put 1 times 5 is 5. And I know that 25 divided by 5 is 5. Okay, I know this is really quick, but I hope this helps you figure out how to multiply a fraction by just a whole number. Here are some problems I want you to try. And that's the end of it. Simple as that. The next thing we're going to talk about and touch on is multiplication as scaling. What does it mean to scale something up or down? Well, that just means that we're going to make it greater or lesser, or we're going to enlarge it, or we're going to shrink it. Let's take a look. This all has to do with number sense. Number sense is so very important. So here we look at this, the visual learning. How can you use number sense to evaluate the size of a product when multiplying a fraction by a whole number? Here's our word problem. Sue knitted 4 scarves, 4 feet long, for her friends Joe, Alan, and June. After a month, they compared the lengths of their scarves. Some of the scarves had stretched, but some of them had shrunk. The results are shown in the chart below. How had the lengths of the scarves changed? Think of multiplication as scaling or resizing. So I'm going to take a look at that chart over there. Sue's is still 4 feet long. Joe's is 1.5 times longer than the original 4. Alan's is 3/4 the size of the original 4. And June's is 3/3 the size of that original 4. Interesting. One thing we can do is we can draw a picture. We can perform the multiplication indicated in the chart and use a number line to compare the new lengths of the scarves. So, there's Sue's scarf. She's the original 4. We have Alan's scarf, which appears to be shorter now. And we have June's scarf. That's still the same. Interesting. So the picture shows me that Alan's scarf shrunk. So I took 3/4 of the original 4, and it's going to make it less than the original 4. How does that work? Well, I know that when I think of a fraction, any fraction, 3/4 or 5/6 or 7/16, whatever, it's part of one whole. So in order to have a whole something, this would have to be 4/4, and this would have to be 6/6, and this would have to be 16/16. So all of those original fractions right here, they're all smaller. So if I take a whole number, 4, and I multiply it by a part of something, a smaller part of something, I know that I'm going to have a smaller number. So that's how we know that Alan's scarf shrunk. Now, when I look at June's scarf stayed the same. A little confusing as to why they would make it look this way, but we learned in the previous units that whenever you have a number over itself, let's say 4/4, let's say 17/17, let's say 152 over 152, whatever it is, whenever you have those things, they all equal one whole. So, when June's was multiplied by 3/3, that really just means she multiplied by 1. So, 1 times 4 equals 4. So when you multiply a fraction equal to 1, it results in a product that's equal to the starting number. Okay, so let's try some of these. They seem pretty simple, but when you're put to the test, sometimes you can get a little panicky, and not necessary here. I have the fraction 3.5, and I'm going to multiply it by a fraction of 2 2/3. And I need to find out if it's greater than, less than, or equal to 2 2/3. Now, when I look at these, I see that I'm multiplying a whole number with a part by a whole number with a part. And I see that this number and this number are the same. So if I'm multiplying a whole number by a whole number, am I going to get bigger or smaller? I'm going to get bigger. So 3.5 times 2 2/3 is going to be bigger than the original 2 2/3. I just know that from number sense. Let's take a look at another one. Here I have 4/5 times 2 2/3, and I want to know if it's greater than, less than, or equal to 2 2/3. 4/5 is less than 1. So if I'm multiplying something smaller by something bigger, I know that my answer is going to come out smaller. Because I'm multiplying it by part of something, not a whole anything, just part of something. And here's our last one. When I think of multiplying 4 3/5 by a 4/4, just like June, greater than, less than, or equal to 4 3/5, well, this is just a 1. I know that because 4/4 or 17/17, any number over itself equals 1. So I know that those two are going to be equal. Now it's your turn to try some of these. I'm going to put some problems up here, and I want you to go ahead and try them. So I hope that helped, and I hope that it gives you a good start into what we're really going to be doing when we start to multiply fractions, because now you have the number sense behind why your answer should be the way it is.